There, we'll start with this. Officially recording, so happy Thursday. Hope everyone is safe and warm wherever they are. That's what my plan is here. I'm not leaving the house today. It's not going to happen. I want to think we could start with maybe returning back to the example, revisiting person mean centering and constant mean centering and all that good stuff. That sound like a plan? Yeah? Okay. Let's see. So you're familiar with the example. We're looking at time-varying grumpiness predicting time-varying glucose in a model where we're studying fluctuation as opposed to change. So the time component of this is minor, if at all. First things first, we did variance partitioning to figure out how much variance is in each of these variables. So for glucose, it worked out to be an intraclass correlation of about 0.7, so 70% between on that score. With respect to negative mood as our time-varying predictor, it was about 40% between. So what does that mean right away in terms of the potential for the kinds of relationships that we can have? If I have an outcome that has 70% between and a predictor that has 40% between, what does that tell me? What do I need to worry about?
Smooched effects?
Yeah, because I've got the potential. So long as you have a predictor that's not 100% within or 100% between, you've got the potential for the mixing of the two. So intraclass correlation is always a good place to start, just to get a sense as to how much variance is of each kind. I usually get a question about the relative alignment of those. So let's say that you have an outcome that's 90% between and a predictor that's only 10% between. Well, you still have to worry about smushed effects because there at least is some variance at each level, but it's probably not going to go well because they're misaligned. Like only 10% of the information in the outcome would be eligible per se to capture person level variance in the, or 10% of the predictor would be eligible to capture person level variance in the outcome until you start getting into the person level variance that's in the time varying predictors, which is where we're trying to disentangle that. Good. All right, so person mean centering. Do we need to go back over this as a concept? How to make the variables what they mean? Not really. Feeling good about that? Key idea is that you're doing the work ahead of time to make sure that you know what information your predictor variables contain. That way you know for sure what kind of effect they can possibly have. So at level 1, we subtract the person's mean, rendering the level 1 predictor purely within. At level 2, we then reintroduce that person mean centered at a constant so that 0 means something, and that will capture all of the between person information and effect. So we went through most of this stuff. Stata folks, are there any pieces of code here that you want to ask questions about what it's doing or why it's doing what it's doing? We've got labeling effects. We've got building a total R-square by computing the fixed effect predicted outcome and correlating it with the real one, squaring that correlation to make it total R-square, and then pseudo R-square. Had a request for review question about that as well. So first off, Stata folks, any questions on the code, what it's doing, or why? No, we're good? Mostly good? Okay. R folks, I will ask you the same question. I think. Let's go back up. Nope, I have to go a little bit further to get an R example that has all the stuff in it. So rather than ask about R, I'll postpone that for 1 second and scroll back up to the effect sizes. So I have two different kinds of effect sizes here. We have what I call total R square, which is, I have a function to build it here, which is 0.02 in this example. So what that means is that 2% of the overall variance in glucose has been explained by the fixed slopes for negative mood. So that functions the same way as it would in a standard single level regression model, and it's computed the same way. So when I teach regression, I tell them you can think about R square as proportion of variance explained, but you can also think of it as the squared correlation between y and y hat. The latter is what I'm implementing here. So if you want like a comprehensive, how well did my model work as a whole kind of effect size, that's what total R square is for. Comprehensive as a whole. Pseudo R square then is complementary in that it's not redundant information, it's not different information, it's just a more specific way of looking at effect size. This is going into each model equation that has some kind of residual, So at level 2 for the random intercepts, at level 1 for the within person residuals, and asking of that kind of variance specifically, how much did the model account for? So in our case, we have explained about 2.5% of the intercept variance. We know that has to be from person mean negative mood because that's the only level 2 predictor in the model. So level 2 variance explained by a level 2 main effect of person mean negative mood. At level 1, we've explained very, very little variance, less than 0.2%, and that has to be due to the time varying effect of negative mood within persons at level 1. So how those things combine to create a total R-square, that's something that you can actually compute. If a manuscript doesn't give you a total R-square, in these kinds of models that only have one kind of variance at each level, you can actually compute it as a weighted function of the ICC. So if I said, like right here, if I tried to interpret this number as, well, the model explained 2.5% of the variance in glucose, that's not right. The model explained 2.5% of the random intercept variance in glucose. And so then we got to think back to the empty model. Okay, how much of it was there in the first place? And it was about 70%. So what I have is I've explained 2.5% of the 70% that was random intercept. A fraction of a fraction. At level 1, I've explained 0.2% of the 30% that was at level 1 within persons over time. Okay, so folks who had questions about R-square, does that help? If anyone is here that had those questions, or not, you can just hear about it and have it help, or not. So I would typically report both of these things. For models that get really complex in terms of their random effect structure, I might just go with total R-square so that I don't have to keep track of every single one. Plus, they kind of wiggle around a bit, especially if you add non-significant things, they can actually increase the variance rather than decrease or leave the same. So with this method of computing it, you can have negative R-squares. That's one of the advantages of the suite of R-square measures that Reitz and Sturba have developed. That's been on your reading list last semester. And this one is that they figure out, rather than basing it on a model without the predictor, they try to figure out what the total model implied variance would be from the model that has the predictor by essentially adding back in the part that's been explained. So then that way of computing it pretty much guarantees it's going to be positive. That way is harder. And they've implemented it in some R packages, but only for certain kinds of models. So I'm going to stick with this one for the purposes of pedagogy and trying to get the same information out regardless of what package you're using, since there's nothing built into Stata or other packages as far as I know for that. Okay, good so far? Any that you want to hear more about? Feeling good? Okay, next up we looked at a random effect of mood by adding U1 to our level 2 equation to predict beta 1. That would allow each person to have their own version of the relationship between grumpier than usual and more glucosier than usual. Did a likelihood ratio test to check out that. Turns out it was not significant. Would not have been significant when using a mixture chi-square either, so we don't need to worry about that. So what does the result mean in English if we don't have a random slope for within person negative mood? Cough, cough, homework question. These models will be the topic of your homework too in a few weeks. So what does it mean if I don't have a random slope for how within person negative mood affects within person glucose?
It means that it affects everybody the same.
Yep. All people change the same as a function of negative mood, or negative mood affects everyone the same. I'll take that. Yep. And I generated these data to not have a random slope, so I know for a fact that they're all the same. But next thing that we did was look at moderation of these effects without the random slope in the model, given that we didn't need it. So I have created a systematically varying effect of within person negative mood by allowing it to differ by gender, but not as a function of individual differences otherwise. So men get one, women get a different one, but within those groups, the slopes are the same, homogeneous. So that required adding a main effect of gender as gamma O2. It required adding an interaction of gender with the person mean of negative mood over time, and then an interaction across level with within person negative mood. So this latter beta 1 equation then is person mean centered mood times that. And so it's a little bit easier to see that if you look at the way it's specified in the code with 3 main effects and the interaction terms defined as usual. So this one I stacked up all this data code and I'm showing the results in R. So I think we went through this model. Yep, we got effect sizes out of that. And do you want to go through the model results, or are we feeling okay with those? We did them before, but it's been a minute. What do you think? Interpreting interaction practice, or do you got it down? Just practice? Yep. Okay, emphatic nodding while chewing. Got it. Yeah, it's lunchtime. No judgment if you need to eat or snack or do whatever else you got to do. So the men are the 0, the women are the 1. So that means that these 3 effects right here are specifically for whom? You can give me a finger question, 0 or 1. Yeah, 0, always. So these are specific to men. So men who are average with respect to their average negative mood, so like people who are at 0, which is the sample average of that variable, and people who are at a day where they're at their usual level of negative mood. So those are the two, what the zeros mean in the context of mood. So those kinds of dudes have an expected glucose of 4.96, and then within persons, for every unit more for every unit more mood they have than usual, glucose at that next morning is higher by 0.03, which is significant. And then on the between person level, for every unit more person mean negative mood a man has, their glucose on average goes up by 0.18, also significantly positive. Then we get to the main effect of gender, and that is also conditional given the interaction terms. So that would be the gender gap amongst people of average levels of negative mood across the study on days when they're at their average. Both of those things is true. And then we have the 2 interaction terms. Do these tell us what happens in women, or do these tell us how things differ in women? Differ. Yes, good one. So we're saying relative to men, how different are the effects of negative mood in women? And I would call them, what pattern would you call these? More positive, less positive, more negative, or less negative. Less positive. So in women, are these effects weaker or stronger? Weaker, yeah. All that stuff, it goes the same. So all the things you learned about that, yep, they're weaker in women. So then to figure out what they are in women, for instance, if I wanted the within person effect, I would start here and I would add to it the interaction term to describe what happens in women, and those will pretty much cancel each other out and get to 0. I would do the same thing to get the between effect in men, add to it the difference in women to get to what it is in women, and those also result down to about 0. So then the rest of this is just getting additional information with which to tell that story. Do I want to know if the overall moderation by gender is significant? An F-test will tell me that. So I have used contest MD, where I've turned on the main effect of gender and then each of the subsequent interactions, lump those together as a 3-slope test, 3 degrees of freedom. So survey says yes, indeed. And then I did this for future me, remember? So that when you're looking at these models, you don't have to re-figure out what the hell all this stuff means. Future you will appreciate this labeling system. So I wrote out everything that I might want to know, even though some of this is already covered by the model. And so I note up at the top, the ones that are truly necessary as additional results that you could not get from the default output are any of the slopes or intercepts for women as the alternative group, as well as contextual effects. And so that was the new part that we were starting to talk about at the end of last time, contextual effects. So the contextual effects in this model are arrived at only as linear combinations. The way that you can figure out how these minus ones and ones work is by taking what the between person effect is and then literally subtracting the within person effect in terms of the patterns of zeros and ones. So for instance, if I start with, let's see here, the one for men, we take those two lines right here, we end up with, stop it, we end up with 0, minus 1, which renders a minus 1 spot right there, and we end up with 1 minus 0, which adds a 1 there. For the women effect, you end up multiplying the same pattern of minus 1s and 1s in the interaction term spots because women are the 1 there. So you essentially just carry them over. And so that's where this pattern came from of minus 1, 1. That creates the context effect in men, adding to it the extra minus 1, 1. That adds the difference that women get. So then you end up with the context effect for women. And if you just want to know the difference in the context effect, that reduces to just the difference in the interaction terms for between versus within. Where is the minus 1 and 1 from? So if we look at, see if Word will let me do this without getting it in the way. Like if we look at these two right here, the second one, and then subtract the first from it. So the second spot is 0 minus 1 in the result. The third spot is 1 minus 0. As a general principle, if you put a minus 1 and a 1, you're asking for a difference of slopes. So context effect is between minus within. So that's what we just created for men under person mean centering. For women, it's a more complex pattern, but I can try to highlight those. There we go. So if you do the math, 0 minus 1, 1 minus 0, 0 minus 0, you end up with the minus 1, 1 pattern that you see on the women line, the second from the bottom. In Stata users, you don't have the list of zeros and ones, but the same premise holds in having the zeros and ones and the minus ones multiply your variables in the lincom. It's the same pattern. If you have a 0 in it, you don't have to write it though. But my philosophy in writing these kinds of statements is usually to write out whatever could be included given what is eligible. So for instance, like I know if I'm talking about the between person effect, the only terms that would be relevant would be the ones that have person mean negative mood in them. So the main effect slope and the interaction with gender. So I wrote the main effect and the interaction in the first line here, even though the interaction doesn't contribute, to sort of remind myself that, oh, hey, sometimes it's going to. So I include like what's eligible, and then I put in the pattern that I want. So the same thing then would result in the zeros and the minus ones and ones then show up in building the context effects with the same logic. So in homework, I will generally ask you to find an effect for one thing, an effect for the other thing, and then the difference. And those all fit together. Like if you know what the difference is the interaction, you can work backward to figure out what it would be for the non-reference groups or other values of a moderator more generally. Okay, did that help? Minus 1, 1 land? Okay. Go back to the output. So in terms of effect size, there's only two variance components in this model. There's a level 2 intercept, and then there is a level 1 residual. Which variance did the main effect of gender account for? Which one would it have targeted, I should say? Level 2 or level 1? We can make this into a finger question. Main effect of gender. Yep, it's a people thing. In this study, it was measured once, and they had 20 days of observation. So yep, it has to be random intercept variance. Gender could potentially explain why some people have more glucose on average than other people. What about within person negative mood by gender? Random intercept at level 2 or residual at level 1? Yeah, it's 1 this time because there's no random slope. If you have a cross-level interaction with a level 1 predictor that does not have a random slope, it has to explain residual instead, systematically varying. Last but not least, gender by person mean negative mood, 2 or 1. Got 2 votes for 2. Can I repeat? Yes. The last interaction of gender by person mean negative mood, did it account for level 2 random intercept variance or level 1 residual variance? Gender by person mean negative mood. Oh, we got people reconsidering now. 50-50 shot. So let me ask you this. In this study, is gender a people thing or a time thing? People thing. Because it was 20 days, they didn't ask the question again. Is person mean negative mood a people thing or a time thing? Person mean negative mood. The average of the rows for the person. Person mean negative mood. Yet it started out as a time thing, but we've aggregated over the occasions for that person and created a people thing out of it. So it is at that level a people thing. So if I have an interaction between 2 people things, does that explain level 2 people variance or level 1 time variance? Yeah, people variance. Yep. There we go. It gets tricky to try and figure out what these things are targeting, but theoretically, every fixed slope you put in the model of whatever kind is targeting something. So it's just a question of using the logic to figure out what should have been reduced. Those are the high points I wanted to make about that. I made a picture. We talked about the picture. Do we want to talk about the picture anymore? No, we're good. All right. So grumpiness affects dudes more. The end. That's what this picture says. Both between and within. And in terms of explaining additional variance with our interaction terms, we picked up another, let's see, 3.5% of the total variance. So in glucose, we've explained 5.5% of it, give or take. And then with respect to pseudo R-square, we picked up another 4% of the intercept, another 0.5% of the residual, and in total explained about 6% of the people variance and very little of the residual variance across time. Okay. I'm skipping M plus for now. Permission? I included this in case any of you need to use this type of model in your project and want to know how to do it in that scenario. But this is multi-level structural equation modeling software fitting the exact same damn model. Except it's using ML instead of REML, because REML is not a thing in MSIM. So I have that in here as well as all the output. Okay, turning the page then. Any questions before we do that? No. Okay. So changing the model framework then to be constant mean center. Constant, why do I keep saying that? Constant centering or grand mean centering. So I say constant centering to make the point that it doesn't matter what constant you center at. That only changes what 0 means. It does not change the information that the level 1 predictor has in it, and that's the purpose. That's the point. So we're centering a number, not a variable, in this approach. So in this first model, I have committed the cardinal sin of smushing. How do I know that? Mood is only in level 1. Ding, ding, ding. Yeah. So I've centered it at a constant, which means it has all the level 1 and level 2 information that it originally contained still there. And it was about, what was it, 40% between, if memory serves, so quite a bit. And if I only put that one predictor in that contains 2 variables in it really, then that one slope has to do the work too. So in terms of output, we end up with the coefficient of 0.012 Relative to the person mean-centered model, that coefficient was 0.011. So very close. So you might be saying to yourself, what's the big deal? Third decimal place moving up 1, I can live with that. But there's a bigger deal that's sort of implied but not obvious. What's wrong with this model?
It's
2.
also assuming that the between slope is that much.
That's exactly right.
Correct.
Yep. So this becomes a problem when you think about if your interest is in level 2 predictors and you want to make sure that you control for things, you have not adequately controlled for the contribution of mood if you've smushed it, because the between effect doesn't get to be what it really should be. It's stuck at 0.012, which I know for a fact from the previous results should have been 0.07. So it's way underestimated. I've actually seen this problem result in intercept variance that increases because the smushed effect is so wrong it actually makes the model worse. You can make it worse that way, yeah. So that's the problem. It's not that the level 1 effect is biased very much in most cases. It's that the level 2 effect is going to be too reliant on what should happen at level 1 where it should be its own thing. So that's not good. And another way that we can tell this has happened is if we look at explained variance from this model. We should have had way more variance explained in the intercept. It should have been up to about 2%, I think, if I remember correctly, from the comparable model under person mean centering. And here it's much less because the effect that level 2 has been given is too small. The effect at level 1 is pretty close, and the variance it explained is pretty close as a result to what it should be. So let's fix it. So I am fixing the smushing problem, not by carving up the variables into their level-specific parts, but by letting the math do it for me through unique effects. So I'm leaving in mood centered at 0 at level 1. It still has level 1 and level 2 information in it. I'm now adding in the corresponding level 2 variable. So what does level 1 have uniquely? Just the within part now. So then it ends up that we have the exact same coefficient from the person mean-centered model here too. So even though it's a different variable at level 1, it still results in a correct within person effect. Meanwhile, what do I call this one? What is a label that I would use for the effect of person mean negative mood in this specification? Contextual, ding, ding, ding. So this is the effect of being a grumpy person after controlling for how absolutely grumpy you are today. Context effect represents the extent to which your mood is, being a grumpy person contributes over and expected just being grumpy on one day. The extent to which your score is not extrapolable just from considering the days, that how you are on the rest of the days nevertheless impacts today. That's the idea. And so this then, when added together, these two numbers give me what? Between effects. Yes, indeed. So between minus within is contextual. Within plus contextual is between. With respect to the fixed effects, you can get back and forth. And lo and behold, here's all three coefficients on the same screen. Question?
Quick small question. What does TV stand for again?
Time varying.
Time varying. Okay. Thanks.
Yep, no problem. That is a fairly common acronym in the methods literature. You will see TVC for time varying covariate or TVP for time varying predictor. I'm labeling it, so I'm trying to differentiate how the level 1 variables are built. So I named this one time varying negative mood because it has all of the information in it and it's been centered at 0 to remind you that you got to think about that. I named the other one WP for within person, meaning that's the only part of the variable that's in there. And then I used to name this one BP for between person, right? But then I get to this model, I'm like, actually, that's not what it means anymore. So we're sticking with person mean, because even though person mean negative mood is the same variable under person mean centering as under the current constant centering, what it means is different depending on what it's paired with. That's the messed up part of all of this. So there's actually, I'm going to skip ahead a little bit. There's a chart that I've made every time I teach this, and I put it in an article, the review article. This is my smush chart. So this is slide 37. Let me go over this here as a way to try to drive home these points. So I wrote this article with a former student where we were somewhat agnostic as to what the levels were, because we had like a clustered example and then a longitudinal example. So when I made this table, I decided to go with W and B for the subscripts, within level, between level. So the first part of the table describes what happens under variable centering, meaning you're subtracting the person mean and longitudinal data, or you're subtracting the cluster mean and cluster data. And the second part of the table here, the last rows, describe what happens under constant centering, where you're only subtracting a number, a fixed constant, from level 1 instead. So I have C1 for level 1 centering constant, C2 for level 2. So the first two rows here, in terms of what happens, describe more succinctly than I can why I like doing it this way. So if you put this version of the predictor in, like the within person version, or the purely level 1 version, you get the within effect. If you leave out level 2, you assume it's 0. If you do the opposite, if you only put in person mean whatever, the mean of x, then that's the between effect. And if you leave out the level 1 predictor, you're assuming it's 0. And if you put them both in, you get both at the same time. The end. Cool. Now under constant centering, if you put in level 1 all by itself, you are putting in a smushed effect, meaning that the between effect that's implied by the model is supposed to be the same as the within. So here, leaving something out doesn't mean that it's 0. It means that it's the same as what happens at level 1. The context effect for the difference is 0. That's what this is saying. So a smushed effect is saying within and between have the same effect, or there's no context effect for how they differ. You can explain it either way. If I put in only the level 2 part, then that's not different than the other way. And so it goes back to between. And when they're both in, they switch meanings yet again to within contextual. So I don't know about you, but this makes my head hurt. And this, we only talked about main effects, right? We haven't gotten to interactions. So trying to figure out if your interaction term has been smushed, that's also a thing you'd have to figure out, and it is sometimes deceptively challenging to do so. Okay, hang on. Let me go back out. All right, how are we doing? Okay so far? Thumbing? All right. Hide meeting controls, go away. All right, more complicating factors then. So we did most of this. Now how about random effects? Now I will tell you, this is something that I did not understand until just a few years ago. If we look at this equation, I'm asking a question about whether the within person effective mood differs across people, right? Do people react the same to being grumpy? That's what this is supposed to mean, right? But if I follow this U over to beta 1 and bring it up here, U1 is multiplying the original version of the time varying predictor. But didn't we just say that's bad and we needed to put in the person mean? So this random slope here is actually smushed too. The same logic on both sides of the model. The fixed effect of a level 1 predictor, when it's all by itself, has to do the work of level 1 and level 2. We put in the mean at level 2 to solve the problem as a fixed effect. A random effect of a level 1 predictor has to do the job of level 1 and level 2. And we put in the person mean of the predictor to solve it? Like, well, we did that before, but that would involve a random slope of a level 2 predictor in a 2-level model. Exactly, those faces. Like, no, that breaks the system. That can't be a thing. But that's what would be required to solve this. So this random slope is smushed. And so that's why I have in capital letters here, for comparison with Model 2B only because the random slope is smushed. So for many years, I knew that if you fit the model both ways, you did not get the same answer for the variances. And other folks have written about why that might be. It wasn't until a recent paper, again, Reitz and Sturba, figured out the math, I think this was his dissertation, as to what it actually meant and how you would solve it. And the answer to solving it in this model is to add a random slope of a level 2 predictor. It's messed up. We will see that more in play in the next example. It's so messed up I couldn't even come up with the notation for it, and I had to use another punctuation mark as the symbol for it. Interrobang is what I'm going to use. You'll see that in example 3. So this is an incorrect specification, but it's not easily fixable. So for comparison's sake, I have what the previous model with the person mean-centered level 1 predictor had in it versus the variance from this one. They work out to be very, very close because both of them are 0 in the population model. But in general, you will see often smaller variances when you fit a constant-centered random slope than the corresponding person mean-centered. Not necessarily, but usually that has what has happened in practice. We'll talk more about that next week. But that's just sort of a plug for right now that this is a misspecification as well. Okay, last model then, moderation. So if I look at the equation, there we go. Is this model the same as what we had before in examining moderation or not? What's your intuition tell you? I'll tell you everything is the same except for this one variable right here. The question is, what are the downstream implications of switching it out? Sort of. Yes. Way to hedge your bets. I would accept sort of. The question is then, what do you mean by that? And you can phone a friend.
Well, I just mean that like it's the big average of mood and not like the the other one. I guess that one would be the between before.
Hmm?
And it ends up, yeah, I'm gonna stop talking there. That's all I know.
Fair. Would anyone else like to talk or type?
Are you going to be moderating the contextual effects instead of the between effects?
Ding, ding, ding. That's it. You're moderating contextual and within effects because that's what this model gives you. So at level 1, you end up with the with on effect, not because you set it up that way, but because the math did it for you. At level 2, you're stuck with the contextual effect because of what you put in at level 1. That means any level 2 moderators are going to moderate the level 2 contextual effect. Yep. So I would accept sort of, in that these models are likelihood equivalent. They will generate the same predictions, they will fit the same, they will explain the same variances and all that stuff, but they are rearrangements of each other. So that means that if you did want to see between level moderation, what do we do? Remember how to get to between from contextual? Yep, within, between minus within equals context. Add 'em up, add 'em up, fire. Yep. That song is dead to my son, though, by the way. I don't have to listen to that anymore. It is currently the final countdown over and over again. I'm like, I hated it in 1987. I still hate it now. Anyway, Kindle for the win. Yes, add 'em up. That's what we're doing. So linear combinations to the rescue. Before we had this weird pattern of minus ones and ones to get to the betweens. It would be, find them here, a bunch of ones instead of minus ones because we're adding stuff together. So if we take the within effect plus the context effect, that gets us to contextual, or nope, hang on. Within effect plus contextual effect gets us to between for men. Then we add in the interaction terms to get us up to women, and the interaction terms combined tell us how the between effect differs. So you can get from one to the other. Now, why am I torturing you with this? Do you remember why? I swear I have a reason. I can think of two, actually.
Because you might not know what you're getting out of your model, like in M+, and so you can go back and forth between them.
Yep, because multi-level modeling and structural equation modeling software are ambiguously connected in terms of whether you get between or contextual. And it is a problem in M+ that's multiplied by, it changes based on estimator too. And the other reason is in reading the literature. If you come across a model where someone has it set up this way, you need to know whether your level 2 effects are between or contextual. Let me show you an example, skipping around the slides a little bit. This is from a different paper that I wrote where some of the reviewers were like, why does it matter if you call it between instead of contextual? Aren't they synonyms? Nope. So this is slide 29 here. This is clustered data. So the first slide here describes a pattern in which you have a positive slope within. You have pretty much the same slope between, and there's very little contextual effect. So like the lines are all converging onto one big slope. That's the convergence effect idea. And to the extent that there would have been a context effect, the lines would have diverged vertically instead, like the up and down slope that I told you about last time. On the bottom is a different pattern. So the examples that I came up with for the top, for instance, a contextual effect is minimal. There's no additional benefit of going to a high SES school, looking at student SES when comparing across schools at the same level of SES, whereas the bottom would be a contextual effect that's negative. So now we have this pattern where they're split apart, but in a way that's unexpected. At the same student SES level, relatively high students from low SES schools may do better than relatively low students from high SES schools. So you can have, because the context effect is the difference, if the between effect is weaker than the within effect, that will pull the context effect negative. So then you have things that are in different signs that are all supposed to be at level 2. So trying to figure out which you have is, I think, important in talking about people and context, stuff like that. Okay, let's see here. That's data, folks. You get to the R, folks. Oh, picture again. Oh, I made another picture. So look, I put the line in. So if I wanted to make a picture that shows all three within, between, and contextual, I have to change the y-axis, or the x-axis, excuse me. The other picture I had within person negative mood as the x-axis, where I had like lower than usual, and then higher than usual, where usual would be whatever your mean is, regardless of what that happened to be. I've swapped out that x-axis for a different one that contains original daily negative mood. And so that means that my different grumpy people are spread out more. So the blue lines are still for dudes, the red lines are still for chicks. There is a dashed line through the person means here to the best of my drawing ability in Excel. That would be the between effect. The slope of the individual lines is the within effect still, but now this vertical distance across tells me at the same absolute level of daily mood, like for someone with the score of 0, not 0 relative to their own, but just straight 0, what is the extra added impact of being a grumpy person? That's the context effect. So if you want to show context, your x-axis needs to be the original variable. If you want to show just within and between, it doesn't have to be that way. So it's something to think about when you're presenting your results and making your project. All right, then let's see. Total R square, pseudo R square, variance explained, all the same premise as well. And there's the code that I did to do that. And there's M plus, and I think that's it. Oh, words. Yeah, words, lots of words. So note that the way I wrote this up is not the order of the models as presented. I sort of put them all together into like one story in the way that I would probably do it in practice, as opposed to putting in wrong models, for instance, for pedagogy. Okay, any questions on that? Feel like you could do this in Elmer or mixed or whatever? I think you can. You'll get a chance to show me in a couple weeks. It'll be one of the 2 canned data assignments this semester because I can easily control that kind of software and make sure that it gets all the same answers. Let me go back through some of this stuff here. There, I hid the algebra from you last time. But no, don't frown at me. You don't have to follow this. But for those of you who think in terms of equations and you're wondering how can you show that these models end up to be equivalent, this is a very well-known set of derivations, or whatever you want to call it, to do the algebra behind this. What I did is write in the same model with just main effects at the between level, main effects at the within level, and then I rearranged it into how you get to an equivalent model down here. And so then the translation of the parameters, how they map onto each other, is summarized in this table. Your intercept is the same either way. Your within person effect is the same either way. And then what you get at level 2 swaps out. You get context directly if you've only centered your level 1 predictor at a constant. You get between directly if you're using person mean centering, but you can get back and forth. So this was, I want to say they knew this in the 80s, probably. Extensions of it, I think, are less common. So just to talk briefly about interactions and smushing, anytime that you have a level 1 predictor that is constant centered, you have to be aware that any interactions with it will also be smushed in addition to its main effect. So for instance, if I have a question about time varying stress interacting with membership in some kind of group. So if I do person mean centering, the interaction between level 1 and group would say, does the within person effect of stress depend on what group you're in? At level 2, that would be, does the between person effect of stress depend on what group you're in? And if you forget this, you're just moderating at one level and not the other. You're assuming there's no moderation at the level you didn't put the interaction in. Cool. For constant centering, though, it works out to be the same if they're both included, in that you get level 1 moderation as does the within effect differ between groups. Level 2 is does the context effect differ between groups rather than between. But if you forget the second one, then the first one is saying moderation by group happens to the same extent for the within effect as it does the between. I'll say that again. Smushing an interaction, a cross-level interaction, is saying that moderation by group happens to the same extent for the within effect as for the between effect. So smushed moderation, as it were. Here's some more proof. Here's working out how all the interactions map onto each other. So I implemented the results of this in the example to show you how you get from within and between and contextual and the last 2 going back and forth again. So the between person slope in the person mean centered model is equivalent to context plus within. The interaction moderation between by group is built the same way. Context directly is a subtraction within the person mean centered model and given directly in the constant centered model. And the cross-level interaction between something like this would be equivalent. So like I said before, I had to work through all of these things as a way of fighting with someone who tried to say that this person mean centered version of the model is wrong and that theirs is right. And I'm like, no, like math don't care. So that was where this came from. How about intra-variable interactions? Have you thought of those? I know, right? Among the parts of the same variable. So I can have the 2 parts interact. So I could have within person by between person, in person mean centering, and that would be, does the effect of more stress than usual depend on how much stress you tend to have? between person trait interacting with the within person state. And if I follow the pattern of allowing moderation to happen at both levels, it works out to be a squared term. Like if person mean X in pink here is the moderator, just like group was, and I have it interact with both of them, this creates a squared term. So we will see that in next week when we start talking about accelerated designs a little bit more. Under constant centering, we would need the squared term for sure to unsmush the cross-level interaction. So take-home message, can you guess what I'm going to say as a recommendation for practice? Person mean centering for the win. That's why. Then you're not screwing anything up accidentally. All right, yeah, so algebra, more algebra, it works out to be the same. Here's where it's not the same, random slopes. So backing off the interaction terms for a moment just to make the point. When I write out the two-level model in composite form like this, U1, that is contributing to beta 1 here, directly multiplies whatever the level 1 variable is. So here, the random slope is multiplying the within person centered version of X. So it's multiplying just the within part of the time varying predictor. Whereas in the comparable constant centered model, it's multiplying the whole thing. So the random slope here is smushed. So for yet another reason, person means centering for the win, because your random slope is not smushed in that case. It is capturing only between person differences in a within person slope as intended. So summarizing a little bit here, in terms of preventing smushed slopes, two strategies. If you're using variable centered models, then you don't need to worry about this. Your level 1 predictor can only have a within person relationship. The person mean can only have the between person slope. You're good to go. If you are using constant centering, you need to make sure that whatever you do to the level 1 predictor, you do to it at level 2 as well. So if you interact something at level 1, you interact it with the person mean. If you interact the two halves together, you create the squared term, all that stuff. On the random side, though, you don't have as many strategies that are going to be practically estimable or understandable, quite frankly. This is already out. This is on your reading list, by the way. I forgot to update the slide. So if you're using person mean centering, then you're good. Then the random slope is only multiplying the within person part. It is creating slope heterogeneity in that within person effect across people. You're good to go. And under the hood, what is also happening is that it's creating heterogeneity of variance along the within person predictor. So do you remember when we added time slopes to the model that were random? That changed the pattern from compound symmetry to some kind of not constant. The pattern of variance that's given by a random slope is quadratic. So it causes the variance to increase relative to some minimum when you add a random slope along that variable. But if you are using constant centering, then you're forcing the same pattern of quadratic heterogeneity of variance, this thing, along the variable on both levels. So you're introducing what is known as intercept heteroskedasticity. I know, it's a lot. If you want to know more about this problem, you can read the article or you can talk to Vladimir, because this is what his master's thesis has been about. He's been working on for quite a while. It's a little complicated, as you might imagine. So to solve it, what they propose, and what I have had very little success in actually implementing, is a random slope, and I'm using air quotes, at level 2. Because that's the analog of adding in the person mean to unsmush the fixed effect at level 1. You would add in a random slope of the person mean to unsmush the random effect as well. And that is weird and impossible. It's not really a random slope at that point. It's a heterogeneity of variance parameter, analogous to location scale models. And they figured this out in the 80s too, by the way. He found a whole bunch of like newsletters about multi-level modeling that these people wrote to each other like they're friends. Seriously. And they're like, yeah, it's not the same, and this is what it means, and this is what it means, and I don't know. And then they just sort of like died out of the literature until the late, I don't know, 2010s, and then it got picked back up again. So I went with this symbol for it because the two level notation falls apart when you try to introduce something it was not designed to do. So this thing is an exclamation point and a question mark at the same thing. It's called an interrobang. It's a real thing. And I think of it as the WTF punctuation mark, because that's what it looks like. So that's what I say when I see a random slope of a level 2 predictor in a level 2 model. WTF. All right. What about categorical predictors? Do you think we need to worry about this for those? Yep. There's another article on your reading list about that. I think it's this semester, either that one or the last one. So yeah, if you have a 0-1 predictor, you may think that you're good to go with just constant centering, but note those can be smushed too. The problem is that person mean centering is weird in this context. So if I have something like a 0 or 1 is possible at each occasion, and the person mean is 0.4. So if I do within person centering, then I end up with possible values of negative 0.4 or positive 0.6, neither of which is a thing that can happen on a 0-1 variable. So then you end up with an intercept that's like some kind of average that doesn't map onto any direct interpretation of what 0 means, which is a little bit weird. So you can use person mean centering still, it's a little weird. Constant centering is much more common for this, but then you run the chance of smushing slopes. The other thing is that not all time varying predictors are things that you can think about as transient. So if you think of an example of, there's one study that asked, did you have a stressful event happen today, yes or no? And that was it. So you can imagine people saying yes on some days and no on others, and that can go in. But if you have something like whether or not there's a project I'm thinking of, whether or not you are convicted of a crime. There's a before period and there's an after period. And like once you've been convicted, like you're not going back. Like that is sort of staying with you as something that you carry forward. And even before you were convicted of a crime, your behavior or outcomes prior to that may have hinted that that was coming, right? Like you may have been on some kind of different trajectory than people who were not convicted. I think of this in terms of like dementia group. So when I was working with older adults, they would have some kind of point of diagnosis where they would switch from a 0 to a 1. But it's not like you didn't see that coming. I mean, the people who are eventually going to get diagnosed looked different even before they had their 1 hit, and then they don't get undiagnosed afterward, like they're stuck that way. So rather than come up with like a person mean for a proportion of the time that you were diagnosed, like that's a little weird, I would do it differently. I would think about kinds of people. So in that situation, I would make a new person level time invariant predictor for whether or not you're ever going to be diagnosed or convicted or whatever permanent thing is going to happen to you. And that goes in as a level 2 moderator. So then you can see if the intercept looked different beforehand, if the slopes look different beforehand, and all that stuff. So different kinds of people based on what's going to happen to them. Because logically speaking, only the people who are going to have something happen can show that before and after acute effect. The others are constants. They had it the whole time or they never had it. So that becomes a nested effect essentially at level 1 that's not applicable to everybody. So then that kind of separates that out. I've had a couple other examples that students have asked me about. So there was one where as whether or not you had a shift in mentor in some kind of like big sister, big brother program. And shifts in mentors could happen because the mentor decided they didn't like the kid anymore and didn't want to be partnered with them. So the shift in mentor may have been like a sign for other issues that would have been present before that shift happened. Same kind of thing. Family composition was another example I thought this worked well with. So there are some families with respect to fathers who are always present. There are some families where fathers are never present. There are some families where they had a father and then he left, or they gained a father. Like there's all these combinations. So proportion of time that the father was there is probably not a good characterization of these patterns. You'd want to code for like different kinds of family compositions and then see what happens before and after in the ones that could potentially show change. So for categorical predictors, it's a little bit trickier to think about kinds of people in relation to the ones that are not transient, but the same premise would apply in terms of that. So, all right, we did that. I think we're about done. And that's good timing because it's like 1:37. It's so pleasing when I can actually finish like a unit on a day and not have to start a new one, right? Let me make sure I hit everything. I think I did. In a roundabout kind of way. Yeah, I got all of it. Yeah, so
And
there's
you finished
wrap-up
it
slide.
at the end of the week. So this week you don't have to think about starting a new unit.
I know, it's glorious. Except that I'm not ready for the next unit, so then I get to worry about having that ready instead. But so yes, here's your summary slide as usual. I will tell you what I'm going to do on Tuesday is a little bit different. I'm actually going to give, instead of a typical lecture, I'm going to give a talk that I gave on the topic. So you'll get to see a little bit more of like presentation side, Lisa, although it still has a lot of words and stuff in it because that's just kind of my vibe. And then we'll walk through a series of models that are based on what I did in chapter 10 of my book, but slightly updated to address smushed random slopes and all that kind of stuff. So the context of everything we just said about what's a within effect, what's a between, what's a contextual, and how do you know you're not smushing, this is directly translated into accelerated longitudinal designs. So when kids start at different grades and you follow them through school, when you have adults who are different ages at the beginning of the study and you follow them over time, then you got to separate out what is within person change due to maturation or aging from between person differences that were already there that represent cohort effects. So contextual effects are going to be called cohort effects in that context, but it's the same damn thing. Same set of models. So that's what's coming next. All right, how are we doing? Hanging in there? Okay, questions? Then we can be done a few minutes early. That works for me. Yeah.
I have a question about the projects. I was
Yes.
looking at like, so so we have to have our proposals to you by the 10th. Is that
Of next month, I think, right?
of next month? Yeah.
Yes. Yeah, I need to get those out
Okay.
first.
Okay. All right, cool. And I'm not missing anything on that. Like
You have not.
okay.
Yeah, this week I was trying to figure out how many projects we're going to have, which is going to be 11. And then the outline is going to ask you for information about what you're planning so that I can weigh in, but also when your availability is for actually making sure you can present in class and we can be there. Because each of you is also going to be doing a peer review of someone else's project. So I want to try and make it so that you can at least hopefully be present for the ones that you're in charge of. And then in context, in conjunction with that, I'll give you a rubric for like what I'm looking for specifically and the point totals for each. I think I'm going to wait until I see the outlines before I make it though, so I can make sure that it's comprehensive enough to cover what everyone is going to be doing. And also, one thing I didn't do last time, and now I'm going to learn from that mistake, is if you need to redo your outline, there's a deadline for that too, because last time some folks did not give me enough information with which to guide them, and so I needed to extract more. So you will have the chance to redo your outline if need be. Okay, cool. All right, then accuracy draft of homework 1 is due Monday. You can be finishing that up if you haven't already, and let me know if you need any help. Okay? Cool. Thanks for being here. Stay warm and dry. Have good weekends. Bye for now.